Happy Monday, everybody. Today, what we're going to do is review adding and subtracting rational expressions. I'm going to give you a few problems to try on your own, and then I'd like you either to type in your answers into the attached Google Doc, or if you want to just screenshot, well, not screenshot, like take a picture on your phone and upload that, either email it to me, or if you could attach it to the Google Doc, that'd be great. Then all of the assignments are collected in one place. So, whatever works best for you. I would love to see some work though. All right, so here we go. Two examples. Example 6, if you're keeping track from last week, looks like 4 over 3 minus, and then there's that pretty involved second rational expression. So as you can see in the second line of my work, I started by factoring out a 3r from the bottom of 15r squared minus 9r. I'm left with 5r minus 3. You can check that factoring by distributing the 3r back in. You see that the r's cancel, and so then I'm left with 4 over 3 minus 4 over 3 times the quantity, 5r minus 3. The second step will be to find a common denominator. In this case, my common denominator will be 3 times the quantity, 5r minus 3. Step 3 is to multiply each fraction by whatever it takes to make that common denominator. So you can see that I multiplied the first fraction by only the 5r minus 3 because it already had the individual 3. Then the last step was to distribute and combine like terms. So I distributed in the 4, and that gave me 20r, and then minus 12. And then I subtracted the 4, which was on that right-hand side rational expression. Combining the like terms then gave me 20r minus 16 all over the common denominator of 3 times the quantity, 5r minus 3. All right, one more example. So step 1, factor and cancel. Notice up here in the second fraction, I saw a trinomial. I even saw a trinomial that was, I could factor out a 2. Everything was divisible by 2. Everything was even. I factored out the 2, and that left me with b squared minus or plus 3b minus 18. And then I factored that trinomial. What two numbers would multiply to negative 18 but add up to 3? 6 times negative 3, or 6 plus negative 3. And then that left me with factored form of 2 times b minus 3 times b plus 6. At this point, the 6 and the 2 I can cancel, and 6 over 2 is the same as 3 over 1, or just a 3. Unfortunately, I can't cancel the b minus 1 or the b minus 3 or the b plus 6. The only way that you can cancel a binomial is if the numerator and the denominator contain exactly that same binomial expression. Also, another thing that I bet you're itching to do would be to cancel out this 3 and that 3. No, no, no. You can't cancel across addition. You can only cancel if things are being multiplied together. All right, anyway, common denominator. Well, we're stuck with that 3, we're stuck with the b minus 3, and we're stuck with the b plus 6. So what do I need to do to kind of, level things out? What do I need to multiply each fraction by to make the common denominator? I need to multiply the first expression by the b minus 3 and b plus 6. I need to multiply the second equation by the 3 because it has those two binomials, but it doesn't have the 3 in the denominator. It has a 3 in the numerator. Well, good for it. That's how I had 6 over 2, maybe. I don't know. Okay, anyway, here we are. I've leveled everything out. Then I need to go 5 times, b minus 3 and b plus 6. So what I did was I took these two binomials, and instead of factoring and doing extra work, I said, yo, you know where that came from. It came from b squared plus 3b minus 18. So I just went from here, dumped it back into b squared plus 3b minus 18 form. And then something else I did was I took 3 times 3, and that gave me 9. Okay, I'm ready to keep factoring, distributing, not factoring, I need to keep distributing. So 5b squared plus 15b minus 90, which is 5 times 18. Your calculator will prove it to you. Plus 9b minus 9. And then combine your like terms. 15 and 9, those are both b terms. They combine to 24b. Negative 90 and negative 9 combine to negative 99. You don't need to factor the numerator, you just leave it alone. You don't need to FOIL the denominator, just leave that part alone. So that's a good enough answer for me. Call it a day. All right, so hopefully you're kind of starting to get the hang of adding and subtracting rational expressions. Like I said, in the Google Classroom, I've got some problems I'd like you to try. Work them on your own. Either take a picture of your work and send it to me, or type in your answers. The more work you show me, the more feedback I can give you. All right, I hope you're having a great day. I think it's a beautiful one. Talk to you later. Bye.